welcome to another day on the Journey Chez Chem. As always, you have 2 warm-up questions to answer, and I'll be right back. Number 1 is another conversion. It's very important to go to the base unit and to understand that these 2 values must be equal to one another because a conversion factor is always equal to 1. So there are 1,000 grams in 1 kilogram. And then from there I can go to nanograms, and there are 10 to the 9th or a billion nanograms in a gram. So if we have this in exponential form, it's much easier to do. And this would be the same as 6.5 times 10 to the 0. So 0 plus 3 is equal to 3, plus 9 is equal to 12. So my answer is 6.5 times 10 to the 12th nanograms. And for B, we have centimeters and we're going to kilometers. So my base unit is meters. So I take my centimeters, go to meters. There are 100 centimeters in a meter, and there are 1,000 meters in a kilometer. It's very important that you look and see that those 2 values are equal to one another. And that way you won't make a mistake. So we have an exponent of 2 minus 2, because we're subtracting, is 0, minus 3 is equal to minus 3. So my answer is 1.26 times 10 to the minus 3 kilometers. When I have exponents, I always move in the order that the problem is written. The top number multiplied by 1 divided by 100 multiplied by 1 divided by 1,000. In C, I am using a cubic unit. And so it's important to understand that there are 100 centimeters is equal to 1 meter. And I'm cubing the whole thing. So that is, when I cube 100, I get 1,000,000. So there are 1,000,000 centimeters cubed in a meter cubed. And I'm also going to show you another way to do that. So we get 3.21 times 10 to the 8th centimeters cubed for that answer. In the case of D, I'm going in the opposite direction, so my centimeters cubed have to be in the bottom so that they cancel. So this number is 1.25 times 10 to the 1. So it's 1 minus 6 is minus 5. And the answer is 1.25 times 10 to the negative 5th meters cubed. Now, because this is a cubic unit, a lot of times it creates a lot of difficulty for students. So I'm going to show you one other way to do this problem. In C, I have 3.21 times 10 to the 2nd meters cubed. So another way to do this would be to say that I want to get rid of 3 meters. And I want to get 3 centimeters to give centimeters times centimeters times centimeters is a cubic centimeter. So then if I know the one dimension, it comes out to be the same number. Because this is 1 times 10 to the 2. There are 2 zeros, is 10 to the 2. 1 times 10 to the 2 and 1 times 10 to the 2. So we have 2 plus 2 plus 2 plus 2 is equal to 8. So we come up with the same answer that we had in the first place by doing it in one step. So if you're struggling, it's possible to do it this way, and some students prefer to do that. So the meters cubed cancel with these 3 meters, and centimeters times centimeters times centimeter is centimeter cubed. So that's an option for you to do. Now for number 2, we're just computing numbers using our calculators, and we learned yesterday how to use our calculators. So when we do a multiplication and division problem, the first answer I get, I'm going to cut it off after the 4th digit after the decimal. And then I go back to the original problem. Well, when I look at the numbers in the original problem, I see that there were 2 significant digits was the least number of significant digits. So my answer then would be 2.7. When I'm multiplying and dividing, my final answer should have the least number of significant digits as given in the original problem. In B, 2b, I do the math, I cut it off after the 4th digit, and then I look back to my original problem. And the least number of significant digits in that problem for multiplication and division was 2 significant digits. So my answer is also 2.7 times 10 to the negative 7th. That's kind of interesting that it came out to be 2.7. I was amazed at that. Then in C and D, we have addition and subtraction, which is a different rule. In addition and subtraction, we use the least number of decimal places given in the problem. And in the case of C, it was to the 10th place was the least number of decimal places. So my answer would be 40.2. In the case of D, it also went to the 10th place. And so when I look at my answer and I want to go to the 10th place, I'm going to look at this 8 and it rounds this up to a 9. So my answer is negative 6.9. So it's a different rule for addition and subtraction than it is for multiplication and division. Now today we also have a new topic to discuss, and that would be density. Density is equal to mass divided by volume. Density is mass divided by volume. So D equals M over V. You know, mathematicians always like symbols for those words. So this is my basic equation. If I'm solving for any one of the unknowns and I'm given 2, I can solve for the other. But the first thing that I want you to do is solve the equation for the unknown variable before you put in any numbers. To undo division, I have to multiply. To undo multiplication, I have to divide. So that is the 3 forms that the density equation could have. Now I'm going to give you 2 problems that I would like for you to solve, and then we'll go over them together. In question number 1, we're solving directly for density. So I can just put the numbers right into the equation. I have 15.5 grams divided by 3.6 milliliters. When I do this in the calculator, I get this number. And remember, we always cut it off after the 4th digit. Then I'd look back to my original problem, and this 3.6 has 2 significant digits. So the least number of significant digits in the problem is 2. So I round this to 2 significant digits, and I must give my unit of grams per milliliter. So that was pretty straightforward. Now, number 2 is a volume problem. So I take my original equation, I rearrange it and rearrange it again, and these 3 dots mean therefore. So we rearrange it to get the equation for volume. So volume is the mass divided by the density. And the density has a unit that is grams per milliliter. Well, whenever I divide by a fraction, I have to multiply by the reciprocal. And even though you don't have to do this, I wanted to show you that when I multiply by this reciprocal that is a unit, I handle it the same way as I do numbers. So I flip it and multiply both the top of the fraction and the bottom of the fraction. And that way, my grams cancel and my milliliters cancel, and that gives me 1 in my denominator. And that's why we do that. So it's important to understand the basis of the math and why we do what we do. And it's so that the bottom number becomes 1. And when I do the math here, then the bottom, when I divide these numbers, the bottom becomes 1. My grams also cancel to give me my final unit, which is milliliters. Now I get an answer of 1.2974. And I look back to my original problem, and I see the least number of significant digits given in the problem is 3. So I'm going to look at this 7 to determine what to do with that 9. And I'm going to round it up. So my final answer is 1.30 milliliters would be the final answer. So that's how you do density problems. That's not so bad, is it? And you'll get some practice on it on our next time that we meet. But tonight, you have a break. So take a break, and if you're struggling with those conversions, try to do those again, and I will see you tomorrow.